What's up, guys? It's me, Sir Ernest, and today we're going to talk about or discuss example 7.1.1 of Fowles and Cassiday, 7th edition. The problem reads: at some point in its trajectory, a ballistic missile of mass m breaks into 3 fragments, each of mass m over 3. One of the fragments continues on with an initial velocity of 1/2 the velocity v0 of the missile just before breakup. The 2 other pieces go off at right angles to each other with equal speeds. Find the initial speeds of the latter 2 fragments in terms of v0. Okay, so for example, this is your so if this is your missile, okay, of course we can assume that it is a sphere, and then this breaks apart like that. So as this particle moves, let's say in this direction, so this particle or this missile is split into 3 segments. One is still going straight, the other one is going in this direction, which is perpendicular to this particle. Okay, so let's call this M1, let's call this M2, let's call this M3. So we take note that M1, M2, and M3 are the same, and they're all equal to m over 3. Taking note that the original missile has a mass m, and the initial velocity of this mass before it breaks down, or the velocity before the velocity of this missile before it breaks down, is v0. So let's say m1 will have a velocity v1, m2 will have a velocity v2, and m3 has a velocity v3 after it exploded. We take note that v2 and v3 are perpendicular to each other. Okay, so by conservation of linear momentum, the momentum before and after the breakup should be equal to each other. Okay, so that means the mass, the momentum of your missile will be equal to m1 v1 plus m2 v2 plus m3 v3. And we know that m1, m2, and m3 are equal to m over 3. So therefore this equation becomes v0 equals v1 over 3 plus v2 over 3 plus v3 over 3. Since the velocity of this particle v1 is 1/2 of the original velocity v0, so this is v0 over 2. So therefore this becomes 3 v0 equals v0 over 2 and because the 2 particle goes at right angles at equal speeds, so that means v3 and v2's magnitude are the same. Anyway, this will be equal to, this will be plus v2 plus v3. or simply 5 halves V naught, which is equal to V2 plus V3. Now, if we take the dot product, scalar product of each other with itself, that is 5 halves V naught dotted with 5 halves V naught. This should be equal to V2 plus V3 dot V2 plus V3. Okay, so this can be simplified as 25 over 4 V naught squared. This is equal to V2 dot V2, so that's V2 squared. And then V3 dot V3 would be V3 squared plus twice V2 dot V3. Because V2 and V3 are perpendicular to each other, their scalar products would be equal to 0. And because V2 and V3 are the same, so the speeds are the same but the velocities are different, so this will now be equal to 2V2 or 2V3 squared, sorry, should be squared. So therefore, V2, which is the same as V3, will now be equal to 5 over 2 square root of 2 V2. Numerically, this is approximately equal to 1.77 V naught. Okay, so this is it. This is the initial speed of the latter two angles fragments in terms of V naught. Okay, so that's it. This is example 7.1.1 of Fowles and Cassiday 7th edition. Thank you guys for watching. I hope you learned something today, and I'll see you guys in the next video. Bye-bye.